in this question it is given that let the function fx equal to this have a maxima for some value of x less than 0 and minima for some value of x greater than 0, then the set of all values of p is, you have to find the correct choice. From the language of the question, it is clear that here maxima means local maxima and minima means local minima. You must be knowing that absolute maxima and local maxima are two different mathematical words. Similarly, absolute minima and local minima are two different mathematical words. Before I do this question, I will say, remember this concept that for any cubic equation, if A is positive, either the graph is of this type or the graph is of this type or the graph is of this type. This will be the graph if derivative of this has two distinct roots. This will be the graph if derivative of this equation has no real root. Note that derivative will be a second degree equation. And this will be the graph if both the roots are equal. For complete theory of this concept and more concepts related to it, I would say that please see my video lecture of maxima minima made for JEE level. And because he is saying this function has one point of local maxima for some value of x less than 0 and local minima for some value of x greater than 0. Note that here maxima means local maxima, minima means local minima. Means the graph is of this type. And this will be the graph if the derivative equation has two distinct real roots. That is, derivative equation of this has discriminant greater than 0. Note that for all the three graphs, I had supposed that coefficient of x, that is a, was positive. Let us first find the derivative of this equation. Clearly, f dash x is equal to 6x square plus 2 into 2p minus 7 into x plus 3 into 2p minus 9. And as I just told that for one point of local maxima and one point of local minima, d should be greater than 0. And according to the condition given in the question, for the point of local maxima, x should be less than 0, and for the point of local minima, x should be greater than 0. Hence, according to question, one root of this equation should be negative, other root of this equation should be positive. That is, 0 should lie between the roots. And all of you must have studied while studying quadratic equation. For the quadratic equation, ax square plus bx plus c equal 0, say fx equal to this. For one root to be less than lambda and other root is greater than lambda, for that the condition required is f lambda should be less than 0. In this case, I have supposed that a is positive. If f lambda is less than 0, then out of two roots of this equation, one root will be less than lambda, other root will be greater than lambda. This is the condition. But many students will say, not only this condition, d greater than 0 is also required. But I will say d greater than 0 is not required. Once this is satisfied, this is automatically satisfied. And why? For the complete theory, again you will have to see my video lecture of quadratic equation made for JEE level. Because at the roots of this equation, the function has local maxima and minima. Therefore, one root of this equation should be less than 0, other root of this equation must be greater than 0. And for this, I will say the value of this for x equal 0 should be negative, using the concept which I told you just now. Therefore, for the given condition to be true, f dash 0 must be less than 0. And f dash 0 means 3 into 2p minus 9 is less than 0. Note that once this is satisfied, d greater than 0 is automatically satisfied. Means once this is satisfied, it is sure that the equation will have two distinct roots. That is, I have got the conclusion that p should be less than 9 by 2. That is, third choice is correct choice. Many students will have this question in mind that where we have used the condition that local maxima should be at x less than 0 and minima should be at x greater than 0. This condition simply implies that the equation this has one root negative and one root positive. But the condition that maxima should be at x less than 0 and minima should be for some value of x greater than 0, according to them, I should have done this step also, that first find the two roots of this. At negative root, it should be having local maxima. At positive root, it should be having local minima, which is too much lengthy. But that is all wastage of time. All those things are not required. Why? See, here it is clear that coefficient of x cube is positive, means graph will be of this type. This will be the graph when the derivative equation has two distinct roots. Obviously, at smaller root, note that x coordinate of this and x coordinate of this are roots of derivative equation. Hence, for any cubic equation with maximum power of x positive, at the smaller root, it is sure to be giving local maxima. At the bigger root, it is sure to be having local minima. Smaller root means smaller value of x. Hence, this condition is automatically satisfied that 0 lies between the roots of this. Then it is sure that at the smaller root, local maxima will be there. At the bigger root, local minima will be there. Hence, the only condition for the given information to be satisfied, this is the only condition.